Today's lesson is 2.2, day 1, or day A, adding and subtracting with scientific notation. So adding and subtracting numbers in scientific notation. For today's lesson, you can only add or subtract if the powers of 10 are the same. So today we're going to deal with the same powers of 10. Tomorrow's lesson will deal with different powers of 10 and how we have to adjust that. But that is true. You can only add or subtract if the powers of 10 are the same. So example number 1. A popular, and this can be found in your textbook on page 68. Example number 1. A popular social networking site has the most members between the ages of 15 and 28. Within this age group, there are 5 and 1100ths times 10 to the 7th student members and 9 and 5500ths times 10 to the 7th non-student members. What is the total number of members in this age group? So I'm adding 5 and 1100ths times 10 to the 7th plus 9 and 5500ths times 10 to the 7th. I'm going to add those numbers. Well, yes, I could write them out in standard decimal numeral form, put all the zeros on it and add up all the columns, but that would take much more work than what I'm going to do. They have a common factor, 10 to the 7th, same power. So I'm going to factor that out of this sum. And I'm going to do 5 and 1100ths and 9 and 5500ths, factoring out what they have the same, that 10 to the 7th. So I can do the sum first. So first thing I do, factor out their common factor, which is 10 to the 7th. Factor out that common factor. I'm going to add within the parentheses, and I get 14 and 6600ths times 10 to the 7th. Don't forget that. Now this number is not in scientific notation, so I'm going to adjust this 14 and 6600ths and make it 1 and 466 thousandths times 10 to the 1st. I'm going to put this number into correct scientific notation form. However, don't forget that I still have 10 to the 7th there. So now I'm going to use my product of powers, keep the base and add the exponents, and my answer in scientific notation would be 1 and 466 thousandths times 10 to the 8th. That's the total number of members of students and non-students in this popular social networking group. Let's go to the next example. Well, what if I wanted to know how many more non-student members there were than student members? Okay, so we had non-student members was the 9 and 5500ths times 10 to the 7th, and student members was the 5 and 1100ths times 10 to the 7th. So now instead of totaling, adding them, I'm going to subtract them. So same steps. Factor out the common power of 10 to the 7th and put my subtraction in parentheses. So I'm regrouping this and factoring out the times 10 to the 7th. Go ahead and subtract, and I get 9 and 5500ths minus 5 and 1100ths. I get a number that's in scientific notation, 4 and 4400ths. So I don't have to adjust that like I did with the adding part. So I have the answer in scientific notation. The difference between non-student members and student members is 4 and 4400ths times 10 to the 7th. Next example. As of the 2010 census, the population of Wyoming was approximately 5 and 6300ths times 10 to the 5th. Ooh, not too many people out there. The population of Vermont was approximately 6 and 2500ths times 10 to the 5th. Small states. Find the total population of the two states. Find the difference. So total, I'm going to be doing a sum. Difference, I'm going to be subtracting. So to sum them, yes, they have the same power of 10, so I'm going to go ahead and factor that out. And I have 5 and 6300ths plus 6 and 2500ths factoring out my power of 10, which is 10 to the 5th. Adding those together, I get 11 and 88/100ths, not in scientific notation, so I have some adjustment to do here. I'm going to put that as 1 and 188,000ths times 10 to the 1st times that 10 to the 5th. So using my product of powers, I'm going to keep the base and add the exponents there. And then my answer in scientific notation form would be 1 and 188,000ths times 10 to the 6th. So there's like 1 million people between those two states. Wow. Small. Their difference between these two states, now Wyoming's very large, Vermont's very small, but their difference in the population, well, we take the larger one, of course, which is the 6 and 25/100ths, and subtract the 5 and 63/100ths, and factor out, yes, that common factor of 10 to the 5th. Go ahead and subtract, and we get a number, again, that's not in scientific notation, because you get 62/100ths times 10 to the 5th. So we have some adjustment to do here. So put this 62/100ths into scientific notation would be 6 and 2/10ths times 10 to the negative 1st, because you would have to move it back to the left one to get back to the original 62/100ths number, times that common factor of 10 to the 5th. So I'm going to use my product of powers rule again, keep my base of 10, and add my exponents. Well, one's a negative and one's a positive, so how do you combine 5 and negative 1? You get 4, and my number in scientific notation would be 6 and 2/10ths times 10 to the 4th. So 62,000 people is the difference in those two states. Let's try it again. And again, we have a couple states here. Columbia. Oh, District of Columbia. Okay, the population, it says, example 3, write down all the steps, find the total population of the two states. I'm still going to do this one with you. The total population of the two states. So I can see their populations are very small here underneath. Finding the total, I have 5 and 9/10ths plus, must be 8 and no tenths. And yes, they are both 10 to the 5th. Again, not very populous states. Oh, it's District of Columbia and South Dakota. Wow. So when I add those together, I get 13 and 9/10ths. Again, not a number in scientific notation, so we have some adjustment to do. Put this number into scientific notation form, which would be 1 and 39/100ths times 10 to the 1st times 10 to the 5th, right? And keep the base, add the exponents, would give me 1 and 39/100ths times 10 to the 6th. So about 1 million, a little over 1 million people between the District of Columbia and South Dakota. The next problem wants us to find their difference. So same two states, now find the difference in their population. So larger is the population of South Dakota, 8, taking away 5 and 9/10ths from the District of Columbia. Their common factor is that 10 to the 5th power. Subtracting those, I'm going to get 2 and 1/10 times 10 to the 5th. And that number is in scientific notation, so no adjustment needed. The approximate thickness of a CD is 1 and 2/10ths times 10 to the negative 3rd meters. A slim jewel case is about 5 and 3/10ths times 10 to the 3rd meters. When it's placed on top, what is the thickness of the CD and the jewel case? So I'm going to add those together. When I have very small numbers, I can still do that. 1 and 2/10ths plus the 5 and 3/10ths times 10 to the negative 3rd. Adding those together, I get 6 and 5/10ths times 10 to the negative third. And that number is in scientific notation, so that's fine. I don't have to adjust that. About how much thicker is the jewel case as compared to the CD? So I'm going to subtract those coefficient parts. Times 10 to the negative third. And when I subtract, I also get a number in scientific notation. So no adjustment needed there. The last example here, which is the approximate size of a salamander and a lizard. Here's the lizard here on this rock or whatever, and the salamander on some grass. Find the sum and the difference. I'm going to let this one, let you do this one on your own, and then tomorrow in class we'll talk about sums and differences, and we'll go over this problem. The next lesson will deal with what happens when the powers are not the same. So we'll talk about that tomorrow.